Hey digital identity friends, I'm Lance from RootsID, talking self-sovereign identity. RootsID is an open source development group that builds software for grassroots identity efforts that matter. We engage with SSI communities like Atala Prism, Trust Over IP, Decentralized Identity Foundation, KERI, and Hyperledger, all with the mission of bringing SSI to the mainstream. Thank you to our sponsors at Catalyst. RootsID has just completed our KERI Bridge for Cardano proposal, which was awarded by Catalyst in Fund 9 under the Cross-Chain Collaboration Challenge. The goal was to research and implement the first KERI Backer on the Cardano blockchain. Our budget was $16,000 over a 3-month period. Our CTO, Rodolfo Miranda, was the primary developer. He has been researching the KERI and AC/DC ecosystem throughout 2022, and we couldn't wait to begin this work. In November 2022, RootsID attended the Internet Identity Workshop in Mountain View, California, one of the best collections of SSI minds in the world. We also had a chance to collaborate with the rest of the KERI ecosystem developers, including the creator of KERI, Dr. Sam Smith. We also learned how Glyph is using KERI to implement its verifiable legal entity identification ecosystem, which will be used in banking, telecom, supply chain, and more. We successfully completed the proof of concept of the first KERI Backer on Cardano, and Rodolfo presented his implementation to the KERI working group on December 13th, 2022. Here is Rodolfo's introduction to the KERI ecosystem, followed by his demonstration of the first ever KERI Backer on Cardano.
What is KERI? KERI stands for Key Event Receipt Infrastructure. We're going to simplify that by saying that KERI is a new type of identifier that try to solve several problems with regular identifiers. So this is a full presentation, but I'm gonna really go fast and try to show what we are talking about. So the legacy identifiers are tied to a central authority that is the one that provides the root of trust. So this is what they initially try to solve. How we solve it? With self-certifying identifiers. So the identifier is derived from a public key, and the owner of the identifier has the private key of that. So in that way, he has control of the public key and the private key, and that way he can show that he's in control of the final identifier. The problem with that is that the identifier itself does not support key rotation, because if the controller rotates the key, the identifier is going to change, and so then the thing is broken. So the way to solve that problem is by the so famous DIDs, decentralized identifiers. That way we have the initial creation event, that is the self-certifying identifier as in the previous slide, but then we add several updates, so the key rotations that the controller performs, and we store and link those rotations on the blockchain. So that way we really solve the problem of key rotations. This is the case, for example, of DD Prism. The problem with that, usually there is a problem, is that we are really locked to the blockchain. So now the identifier depends on the blockchain. In DD Prism, it depends on Cardano, and so forth with other identifiers. So there is no truly portability of the identifier. What if we stop trusting that blockchain? So we cannot move it, we cannot replace it, so we are locked, and we're gonna lose the identifier. KERI solved that by extracting all the key events that are on the blockchain to a key event log, and that key event log can be stored in any place. So it can be stored in memory, can be stored in a disk, can be stored in the cloud, can be stored in a blockchain. Can we move from one blockchain to the other? So that's how it solves the portability issue. So this identifier is called an autonomic identifier because of this, because it's self-certifying as is the other, but also can provide the key rotation as in the DIDs, but helps also with the portability of this key event log. The portability has another problem that is called the duplicity problem. Because now there is no blockchain who acts as a trust of what's going on with all the key events, the owner of the identifier can produce an event, sign a contract with this last event, but later on he can make a fork of the key event and change that last event. So those signatures won't match. And in order to solve that, that's when KERI is adding a new entity that is called a notary or a witness, as we regularly do in our lives. So a witness is a secondary root of trust that is watching for all the events and validating that event, producing a signature and a receipt that is go back to the controller. So they can also store those receipts as a proof that the event is the correct one and is the last one. So he cannot fake with the duplicity problem, because the witness will realize that the controller is doing something wrong. What is this project about? This project is about a witness that stores the key events on the blockchain. In our case, the Cardano blockchain. These type of witnesses are called Backer in KERI. So as you see, we reintroduce the concept of a blockchain in the identifier, but with the nice property that the controller at any point in time can decide to replace the backer with another backer. And the new backer can, instead of using these blockchains, can use another blockchain. So the portability issue is already solved. So in summary, we're gonna have a controller that is publishing the key events to a witness that we call a backer, and this backer is gonna write all the key events on the Cardano, providing this total ordering of the events. So any watcher or validator can go and look to the ledger, all the events, retrieve them and validate them. Now I'm gonna show you a simple demo of a witness, that in this case gonna be a backer, that's gonna receive key events from a KERI agent. They're gonna validate those key events and they're gonna store those on the Cardano blockchain as a transaction metadata. That way the Cardano blockchain is gonna be a secondary root of trust that provides total ordering of the key event logs. So this script, I'm not gonna go into the details, but it's a simple script that starts a witness, and we add this parameter that is called ledger, and we pass Cardano. That will allow the new code to do the extra functionality of storing those key events on the blockchain. So if we start this backer, we're gonna see that the witness is created with this AID, but also a Cardano address is created. This Cardano address is gonna be used to submit transactions to the blockchain. In order to submit the transaction, you have to pay a fee. So we create, or we have another funded address. That's every time a new address is created, we fund the new address with ADA. So also, because you need to wait for the blockchain to be produced, and maybe also wait for another extra blocks to be sure that the transactions being submitted, you have to wait several times. Now you can see that the witness is funded with 100 ADA, so we are ready to go. Now we're gonna start a normalization with some port. and then actually the demo. That is this script. That what it does is we pass two parameters to the script. One is the ID of the backer, and the second is the address of the Cardano address of the backer. Actually boot the system, resolve the UV of the backer, and create an inception event that we call the alias root, that we pass these two parameters. And then they create every 1 minute, we create rotation and interaction events to provide more key events to the system. So let's start this demo, passing these two parameters that I told, this one, and the Cardano address, this one. So you see that the environment is unlocked and created. That's the database and the key store. And this is the first inception event. You see ICP, you see the list of witnesses, it's only one, that is the backer, AID. And we add in the A, that's extra data that we normally in the data you pass seals, but in that way we're gonna pass only this address we call CA. That's something that we make, but this is only documentation. So you're gonna see that after a minute you're gonna have a second event in the sequence number 2 that it's gonna be stored on the blockchain. So now any agent that wanna get the key events from this prefix, they don't need to query the witness. They just go and look into the blockchain with this address. So let's do it. We got another script. It's called check Cardano that we have to pass the address. Let me see. Let's pass this address. So this script only depends on Cardano, so it's not tied to KERI. In this case, you should run KERI to validate the call, but in this case, only to retrieve the key events from the blockchain. So that's why we are only importing one library that is called BlockFrost. The other are System and PrettyPrint. BlockFrost, what it provides is an API to interact with the Cardano blockchain. We trust this API, but you can also, if you want, you can run your own Cardano node in your computer, in your system, and retrieve the full blockchain and query by yourself and be sure that you are querying correctly. So this, if you see what it actually this script does is call the API and query for all the transactions submitted by one address. That's what I'm gonna do and print the metadata from that transaction. So this is a Python script, so I'm gonna call that way with the address. So now you see that you have three events actually. One is the sequence number 0. We have the fees that goes this transaction. This is 20 cents of ADA. Well, this is testnet, it costs nothing, but actually in mainnet, this is going to be 20 cents of ADA, and ADA right now for the market is less than 50 cents of US dollars. So you're going to see it's really cheap. And you have the full event with the signatures of the agent, also the witness signature, the backer signature. I had to make because there is a limitation on the metadata that how you can store it in the blockchain. There's a limit of 64 characters, I think. I have to put like in an array, but you have all the information. That's something that can be changed. You have a second event that is, let's see, it's a rotation event that we add extra data here. There's a third event, sequence number 2, that is an interaction event. And if you keep running this process, you're gonna see the others events showing and retrieving from the blockchain.